As we mentioned in many previous lecturing videos, when we do multimedia content analysis or semantic concept analysis, the performance are usually content dependent. So when researchers doing their study, they try to focus on some specific data set and then try to optimize their work to this specific data set. But this may cause some problem because some research team A will say that, okay, our approach is the best. But for the research team B may say, no, my research is the best. So how can we compare the technology proposed by different research team based on the same fundamental basis, based on the same data set, would be one of the most important issue in this area. Therefore, there are some important organizations. They propose standard benchmark or data collection for researchers around the world, like that they can propose their idea and evaluate performance based on the same data collection, such that we can compare different people's work fairly. Okay, and this is why we introduce TRECVID benchmark in the following. And the material in this lecturing video is from this paper published in year 2004, ACM Multimedia Conference. Okay, and you may still remember this guy's name, J.R. Smith, who is also seen in the content-based image retrieval, okay, and visual seek system, okay, one of the most early content-based image retrieval system. Okay, and emerging research area, okay, at that time is detection of semantic concept, okay, that can act as semantic filter and add in search and manipulation. And because of the issue, the data issue I mentioned before, the National Institute for Standardization Technology in United States, they proposed the benchmark for researchers to compare their work fairly, okay, and then this benchmark is called TRECVID, TRECVID. TREC is actually a text retrieval conference, okay, which original even earlier for data processing information retrieval, and TRECVID is specific for video retrieval. So video retrieval evaluation, okay, and you can go to this website, and until now we still can see the latest data collection provided by NIST and IST. They try to provide a common corpus and a common evaluation procedure, such that different people's work can be compared together. The TRECVID 2001, we can see some example query from TRECVID 2001, like find all shots that depict people spending leisure time at the speech. Find all shots from the behind of the picture in a baseball game where he throw a ball that the batter swings at. So we can see at the beginning, the goal of this benchmark is quite high. Okay, this is a very nature language query, and the ultimate goal of such benchmark is to provide the foundation for researchers develop technology. So in the end, we can do video query like this. Okay, and right now, after more than 10 years, we approach these kinds of goal as more and more closer and closer. Okay, and at that time, the method they use is break down the complex information present in query into several component semantic concept. Okay, so this idea is totally the same as the atomic concept and the complex concept we mentioned above. We divided the complex concept into atomic concept. Okay, and we build a set of classifier and then fuse them together. And this is the illustration showing what kinds of concepts in traffic benchmark and traffic benchmark. We can roughly divide them into 3 types: scene, object, and event. So in the beginning, they define several concepts like outdoor, sky, greenery, rock, sand. Okay, these are all scene concept. And there may be some object concept: face, water, boat, rocket, vehicle, news anchor, airplane, or maybe event concept: rocket launch, music, speech, explosion, and so on. Okay, and at the beginning, the first year of traffic is starting from year 2002. They define outdoor, indoor, landscape, cityscape, face, people, text, overlay, instrument, sound, speech, and a monologue. Okay, and after year by year, they sometimes divided a generic concept into specific concept, and sometimes they add new concept, and sometimes they merge some concept. Okay, so the pink value is a special kind of object in the form of personality, like some person X. Okay, like Albright or Bill Clinton. Okay, the arrow denotes the influence of the concept from the previous year to the next. So the definition of concept lexicon change year by year according to the research progress. And right now, there are more than 100 semantic concepts can be described and detected. The evolution of this corpus, the thread is they try to increase specificity, and they try to increase complexity, and the rare concept with fewer training samples. So there are some concepts, they have just fewer training sample, and this will cause significant technical challenge because we have few training data. And then they also try to increase the numbers of objects and events. Like they may increase specificity, like from speech to female speech, from face to Bill Clinton and Albright. Okay, and year 2004 benchmark that it consists of concepts that have more than 50 but fewer than 1,000 samples in the training set. That means there are more concepts with fewer training samples. And at that time, there have been many visual features proposed to detect semantic concept or atomic semantic concept, like color, texture, structure, shape, motion, color histogram, color correlogram, color moment, Gilbert texture, Tamura texture, wavelet texture feature, age direction histogram, moment invariant or template, motion direction magnitude, spatial temporal feature, global level versus region levels. And you may recall most of these visual features have been introduced in this class. And also many audio features like MFCC, ZCR, spatial sensory, roll-off, subband energy, pitch, and also speech recognition. Okay, video OCR. OCR is the abbreviation of optical character recognition. Okay, and maybe some metadata like the time instance and the name of the video clip, the source of video, and the duration of shots. All these can be used as features for us to detect semantic concept. And there may be several detection approaches. Most participating groups use supervised pattern classification and exploit different machine learning algorithms. and there may be some fundamental distinction. Some research group develop generic approach, and some research group develop specific approach. Okay, the generic approach means that they just propose a model, and this model can be used to detect various types of concept. And usually the performance may not be good at all semantic concept. And for specific approach, some research team may develop some specific model that can be used only to some specific concept. They may do very well for such specific concept, but not so very well for other semantic concept. And this is the process in pipeline of the semantic concept detection. So first we will extract features, okay, and then based on such low-level features, we will construct the feature-based model that that such feature-based model can be constructed based on Gaussian mixture model, SVM, hidden Markov model, KNN, and so on. Okay, and then we can aggregate such confidence value or such score. Okay, we can do weighted average boosting, and we can combine result over models that are built using the same features but with different parameters or assumption. Then we may consider a different modality. So we will do cross-media, cross-feature aggregation. We combine the detection result from different set of features or different modalities, and we have to consider the synchronization issue, because we have 30 video frames per second, but we have many audio frames per second. So how can we synchronize them? And then we can jointly consider concept. We can consider the relationship between different concepts, and we can use some rule to do post-processing. In addition to define the data set, they also define the evaluation measurement. They propose the average precision. Okay, the average precision is defined like this. Assume that R is the numbers of true relevant document in a subset in the set of size S. Okay, then Rj is the numbers of relevant document in the top J document. Ij is equal to 1 if the J's document is relevant, and is 0 otherwise. Okay, and assume R is less than S. So here you can see that this value is from the top J return document, the numbers of correct item is Rj. Okay, so this is the ratio of this is the precision. Actually, this is the precision of the if we just return top J document. Okay, and then here Ij means whether it's relevant or not. So if it is not relevant, this value will not be counted. And then we sum all possible return value. J is equal to 1 to S and divided by R. And this measurement emphasize not only the precision but also the rank of the return relevant document. Let's see an example. So assume that the correct video clip is V1, V2, and V3. If the top 10 retrieved answer in rank order is like this. So we first the rank number 1 is V3, and then V7, V10, V13, V1, V4, V6, and so on. Then for the conventional precision, we may say that in 10 return document, we only get 2 correct. Okay, so the precision is 2 divided by 10. But if we want to put more focus on the ranking, then the average precision is defined by 1 divided by 1 plus 2 divided by 5. Why? Because when we only consider the top 1 return document, the numbers of correct document is 1. So 1 divided by 1. And then when we combine if we consider the top 2 document, then the numbers of correct is 1 and the J is 2. But right here we will multiply by 0. Okay, so we just consider the next correct one. So in the top 5 document, the numbers of correct document is 2. Okay, so this is 2 divided by 5. Okay, and so we just sum them together and divide it by the numbers of correct data. So the average precision is 0.47. And the average precision favor highly ranked relevant document. So if V1 can be returned to previous to the second stage, then we will have higher average precision. So it allows comparison of different size result set. And for a specific, for one concept, we can calculate one average precision. In the TRECVID benchmark, they define maybe more than 20 concepts, and for each concept, we can calculate the average precision. Then how can we show the performance of a research team? We calculate the mean average precision, MAP. Okay, this is just the mean of average precision in detecting various concepts. Okay, so this is one of the most common evaluation measure used in TRECVID. Some research team may also use precision at 100. That means the numbers of correct shots within the first 100 result. So we will assume that there are more than 100 relevant shots per concept. We may also use precision at 100. So this is a table showing all the approach proposed in before year 2004 for different concepts. Like for the outdoor concept, there are some research team working on SVM, and they propose cross-feature, cross-model, cross-concept, and so on. Okay, and the following concept detector seems to be performed reasonably work for most participating groups, like outdoor face, people, cityscape, speech, music, new subject face, vegetation, female speech, non-studio setting, weather news, and zoom in. Okay, so for this concept, reasonable performance can be obtained. And there is a trend that the generic technologies are preferred because they have the potential to scale to large numbers of concepts. And this figure shows the performance of different concepts divided in TRECVID 2003 in terms of precision at 100. And they try to evaluate whether if the numbers of training sample increase, will the precision at 100 increase as well? In this figure, we can see, yes, it seems there is a linear relationship between the numbers of training data and the precision at 100. For the non-studio setting, female speech, outdoor, we have many training data and we get higher precision at 100. And for specific concept like Albright and physical violence, we have fewer training data and we get smaller precision at 100. This figure shows the same idea, but for the concept defined in TRECVID 2002. Yeah, we also can see roughly its linear relationship between precision at 100 and the numbers of sample. But we can also see some exception like phase and a CT-scape. We have very few CT-scape training data. We have slightly fewer training data on phase, but these two concepts may be easy to detect. Therefore, we get high precision at 100 for these two data, for these two concepts. By comparing different organization, different research team, okay, in terms of precision at 100, and for different semantic concept, this figure shows the top research team achieve. Okay, so the highest precision was achieved by IBM research, and the numbers are around more than 80%, and the medium part is around 30% to 60%, and the lower part would be below 25%. Okay, and you can see that at that time, for most visual concept, for most semantic concept, IBM achieved the best. And actually, the author of this paper was from IBM. So you can see that at that time, IBM takes the leading role in year 2003. Okay, IBM. And there is also for the female speech, Eurocom achieved the best. For the news subject monologue, CMU achieved the best. CMU. And Olu VTT achieved the best for physical violence. Okay, and so on. And this figure shows the concept defined in TRECVID 2002. Also, we can see that IBM also performed very well. And we can also see Microsoft Research Asia, CMU, DCU. This is Dublin City University. This is also DCU, Fudan, okay, from China, okay, and Media Mill. This is from Netherlands. Okay, so different for different semantic concept, there may be different leading teams. So in general, the detection performance seems to be proportional to the log arithmetic of the numbers of positive training sample, and the deviation from this behavior may indicate the inherent complexity of the concept. Objects in general seem to be harder to detect, and event detection is related to the detection of performance of associated site and objects that are related to the event. And aggregating across model seems important. Across model, across modality, and across concept seems important and can be used to improve detection performance. And better motion features may be required to detect event and moving objects. And in more recent years, not only for traffic, but also many other data collection were proposed for semantic concept detection. And this table shows the this paper was published in 2006 in IEEE Multimedia magazine. We can see that in TRECVID 2002, 10 semantic concepts were defined. In 2003, 70 concepts. In 2004, 10 concepts. And in 2005, there are 39 concepts. In year 2006, there are more than 800 semantic concepts. And actually, many researchers not work for all the 800 semantic concepts. Okay, so many of them just use 39 concepts. Okay, and this is called LSCOM Lite and LSCOM Base. LSCOM is the large-scale concept ontology for multimedia. So the concept is we can describe the whole world just based on maybe less than 1,000 concepts. And if we can detect such 1,000 concepts, we can, based on the distribution, based on the relationship between this basic concept, we can describe complex situation, complex concept around the world. Okay, and this is the ontology showing the LS-COM. So this ontology can be divided into program, location, people, object, activity and event, and graphics. And in program, there may be weather, entertainment, sports. In location, there may be office, court, meeting, studio, and so on. And the traffic benchmark right now is not only for semantic concept detection. In recent years, they also extend the scope to many other research tasks like surveillance, event detection, high-level feature extraction. Basically, the high-level feature extraction is the semantic concept detection. They also do search, rush summarization, content-based copy detection, non-item search, instant search, event detection in internet, multimedia. And right now, not only traffic, but also many other data collection are used for fair comparison. Okay, so although traffic is one of the most important, but right now in research community, researchers tend to release their data set such that people can share the data, share the research experience, and compare performance fairly.